Hello and welcome to the next video in the Programming White Lightning on a Commodore 64 series using the fourth programming language. In this video we're going to take a look at animation and how to animate sections of the screen. And specifically we're going to be looking at scrolling vertically and horizontally sections of the screen. I would highly recommend watching the other videos in this series before this one. Fourth is a pretty different language that you're probably used to, so the commands might not make any sense without watching those videos first. With that said, let's take a look. Alright, I've swapped the disk out and I have our code in from the previous video where we compiled a routine called do it to paint some graphics onto the screen. And to load and compile that code, I'm going to type in 10 load. And as a refresh, I'm going to type 10 space list so we could see the code that we just compiled. Alright, once again, this compiles a word called do it. It's on 2 pages of code. The first page shows us setting the screen color and the border color, and then starts drawing some shapes onto the screen. The little dash greater than on line 13 means look at the next page. And if we look at the next page, we can see the remainder of the commands that paint the screen. So we're going to type in do it, and this will draw the shapes and text on the screen we've made over the last couple of videos. We're going to take this word lightning and we're going to apply some animations to it to get it to scroll. When you're dealing with these scrolling routines in White Lightning, they use 4 shared variables: COL, ROW, WID, and HGT. And they are the column, the row, the width, and the height. And we use that to define the square that we're going to be working with. These are actually defined in 8x8 pixel chunks, or basically characters. Even though it's a high resolution screen, the API works in 8x8 blocks. So we're going to take 14 for the column, so that's going to be about 14 characters over. We're going to work on the top row. We're going to use a width of 9 characters wide, and we're going to use a height of 1. And just a quick reminder of how variables work in White Lightning or in Fourth. 14 gets put in a stack. We put the memory just of column on a stack, and then we call the exclamation point, and we read that as the word store. So 14 is being stored into column, 0 is being stored into row, etc. Okay, we're going to learn a new word here, and that word is SCL8. It stands for scroll left 8 pixels. So when I press enter, you can see that the word lightning has scrolled to the left 8 pixels or 1 character width, and the L is gone from the screen. And of course, we can do that a few times, and you can see that each time we run that word, a piece of it gets moved off. All right, let's refresh our screen. And we're going to reissue this command to redefine the square that we're going to work with. So we're going to do that here. And now we're going to try a slightly different word, SCL2. And what this does is it scrolls it to the left just 2 pixels. And then of course we can run it 3 more times, for example. And you can see that the animation moved the word lightning another 6 pixels over. And if I just do it another time or 2, there we go. Notice how that letter N is in between the 2 different colors, right? Half of it's in a blue, half of it's in a red. That's because the attribute data that's on a screen, attributes being the color of each 8x8 square, doesn't move with the scroll command. We're just scrolling pixels. Okay, so we're going to refresh our screen with do it again. Now we're going to try a slightly different command. So let's reset up our shape here, 14 column. So now the next word we're going to look at is WRL2. This is just like scroll left 2, except WR stands for wrap. So when I press this, you'll notice that the L is now being wrapped to the right side of the square. And of course we can put this command here a whole bunch of times. And here you can see that's a little bit animated. So how do we get to animate it? And we probably want to put this into a loop. So we're going to create a loop. I don't think we've done loops yet. So a loop works like this. You start with the value you're going to be going up to, the value you're coming from, because you're putting those onto the stack. Then we use the word do. And then you tell it what words you want to call. In this case, we want to call wrap left 2 pixels. You use the word loop. Now you press enter. Now we're going to get an error, which is error number 17. And what that error means is this word, and I'm talking about the word do, right, because it has the word do before the error message, can only be used for a colon definition. What does that mean? You can't use do in the interpreter. You have to compile it into code. Okay, so we'll do that. So we're going to compile a word called go, and then we're going to put the command that we want go to be, which is going to be 36 times. So we're going to do a loop from 0 to 36. We're going to wrap left 2 pixels, and we're going to put that into a loop, and then we end a semicolon to end our compiled word. And now we have a word go that'll kind of do this animation automatically. So if I type in go, it moves it. And if I put a whole bunch of goes, and here we've created a short animation. Let's try doing it 1 pixel at a time, except to the right. So I'm going to type in forget go, so we can lose that word. And we're going to create a new version of it, although this time I'm going to do 320 times. And we're going to use wrap to the right once. Get rid of this OK message here. There we go. Now if I type in go, it animates going the other way, 1 pixel at a time. Now let's try animating the entire top row of text. So we're going to forget go. And this time we're going to store 0 into column, 0 into row, but we're going to use a width of 40 and a height of 1. So that'll get the entire top line. All right, and then we're going to define go as 750. So we're going to do it 750 times. And we're going to wrap left 1 pixel. All right, let's see how this goes. And as you can see, the whole line of text now is moving smoothly across the top of the screen. Now it's moving slower than just the word lightning did because there's a lot more pixels being moved. Now, of course, we could forget go here, and we can define this. I'll make it 1500 iterations instead. And we can do it 2 pixels at a time. This way it'll go a little quicker. And this time it's scrolling about twice as fast. All right, let's try some vertical scrolling this time. So let's forget that word go that we just created. Let's reinitialize our screen. And now we're going to look at the words scroll and wrap. This is for vertical scrolling. We just did horizontal scrolling. So let's create a new version of go. I'm going to do this in multiple lines this time. We're going to define the top quarter of the screen. So we're going to start at the top left with 0, 0. We're going to go with a width of 40 and a height of 4. Now we're going to store a value into a new variable called num that we haven't really worked with. Num tells us the number of pixels to scroll while using the wrap command. The horizontal commands had the number of pixels built into the word names, WRL 1, 2, 4, and 8. In wrap, you got to put it into a variable called num. So now we're going to run a loop 96 times, and we're going to call wrap. And that's it. So we're going to type in go. Notice how the pixel data is scrolling, but the color attributes are staying put. Let's change it to scroll down instead. Well, we can forget go here, and then we can redefine it using -1 instead of 1. Take this out here, and now this is scrolling down vertically. Now the word scroll does the same thing, except that instead of wrapping the pixels back around, it just truncates them. So if you use the word scroll instead, we can see that it's going to just scroll off the screen, and now it's gone. Now let's look at the attribute part of the screen. We'll call it do it to repaint our screen. White Lightning provides us with some API calls to animate just the color part of the screen, the attribute section. So I'm going to forget go again, and this time we're going to write a routine that only animates the attribute part. So we're going to create a word called go, and we're going to use the entire graphics portion of the screen. And that's actually a height of 15, because remember, we're working in a split screen mode here. And then what we're going to do is do a loop 480 times, and we're going to call ATTL. It's another new word. This is going to move just the color data in the screen 1 character to the left, leaving all the pixel data behind. So let's see what that looks like. It seems very psychedelic. But as you can see, it moves over 1 character at a time. So attribute data, remember, is the color part of just an 8x8 square. And of course, you get this kind of cool effect where you can move the colors behind it. So you can do some pretty cool psychedelic type of stuff with that. All right, so let's forget that word go. Let's repaint our screen. And now let's look at full screen scrolling. So now we're going to explore the words SCRLX and SCRLY, which move the screen, the entire screen over up to a number of pixels. And here's how it works. Normally your screen is set at 0, right? But if I make it 1, the entire screen moves over a pixel, and I can do this up to 7. Right, I'll just do 7 here. Now you'll notice that it's moving the whole screen, and if we go to 8, it sets the screen back to 0. The way we want to animate is we want to use these commands to move the screen over a pixel until we get to 7. And right before we switch it back to 0, we want to copy the whole screen left 8 pixels. So the first thing we want to do is we want to move the screen in by 1 character block on all 4 sides. And there's a word called H38cal that does this. And you just type in H40cal to go back to 40 column mode. So to try this out, we're going to create a new word called go. We're going to switch it into 38 column mode. And this gets a little tricky. So we're going to start by defining the box, which is the whole graphics part of the screen, as we've done before. And we're going to go into a loop 40 times. And inside of that loop, we're going to do a loop that's 7 times that scrolls the screen over 1 as an SCRLX, moves the whole screen over 1 pixel. Inside of this loop, we're going to do an empty loop, which is really just a small delay. So we're going to loop 125 times and do nothing. This will close the loop that moves the screen over 8 times. We're going to do one more little delay here. Okay, and then we set the screen to go all the way back to the left. We do WRR8, which is wrap the screen right 8 pixels, and then ATTR8 says move the color data as well to the right 8 pixels. This way everything moves over. And then here is the loop for the whole thing. So there's our program. So let's see how well this works. So it technically works. It's sort of smooth scrolling, but you'll notice that it takes too long to copy the whole screen data over. The machine is just not fast enough to do it. So those commands exist. That routine really works well on the Commodore 64 when you're in text mode and you have just custom characters and you can really quickly move, 1K or 1.7K of memory. Here we're moving like 5K memory and the machine just can't keep up with it. But what if we did this idea only using the attributes, right? So let's go back to H40 column mode. And we're going to build a version of this that only scrolls the attributes. So we're going to forget go. And I'm going to quickly rekey this program with one small change. Okay, so now we have a version here where the only difference between this and what we just did a few moments ago is before we were doing WRR8, which would wrap all the pixel data. Here we're just doing the attribute data. So what does this look like when we're animating just the attribute data? Still kind of clunky, but it's a tiny bit more smooth. Now if you want to see it without the pixel data to kind of see what I'm getting at, H40cal, we're going to type this command ATT-off SCLR. ATT-off tells white lighting to not touch the attribute data when using any graphics commands. And now we can run our command again, and you can see without the pixel data, it almost looks smooth. This just really shows that white lightning can't smooth scroll full screen high resolution graphics on a Commodore 64. Actually, I don't think the Commodore 64 can do that either. All right, let's get back to 40 column mode. Oops. So that covers some basic scrolling techniques that you can do in white lightning. Look forward to the next video where we're going to show you some really cool stuff. We're going to start bringing some more of the advanced features and getting down to what white lightning is really good at. Thanks everyone for being patient. I know it's been a long time since I've released a video in this series. I think it's like 4 months, but I've been crazy busy in my life. Luckily, it's all wonderfully great things, so definitely nothing to complain about. All right, I'll see you guys soon. Take care.